Question 7 says, a spherical balloon is being inflated such that its volume at time t is given by V of t equals 3t, where the time is measured in seconds and the volume is measured in cubic meters. And so we want to know how fast is the radius increasing when the radius is 1/2 of a meter. So what it gives us is that r equals 1/2. And from our equation, v of t equals 3t, when we take the derivative of that, dv dt will equal 3. And since we want to figure out how fast the radius is increasing, we want to figure out the dr dt, or the change in the radius. And so to do this, we're going to have to use our equation for the volume of a sphere. V equals 4/3 pi r cubed. And so let's set dv dt. All right, let's take the derivative of this equation, equals 4 pi over 3 times 3r squared dr dt. And we know that dv dt from above is 3. So 3 equals 4 pi times r cubed, or r squared, sorry, dr dt, since our 3's canceled out right there. And our radius is 1/2, so 3 equals 4 pi times 1/2 squared dr dt. And 1/2 squared is 1/4, times 4 is simply 1, so 3 equals pi dr dt, and we have to divide by pi to get the dr dt by itself. And so 3 over pi equals dr dt. And so our answer is the radius is increasing at a rate of 3 over pi second meters per second when the radius is 1/2 of a meter. Okay, so from our question 7, this is part B, and it asks, how fast is the radius increasing when the time is t equals 12 seconds. So what we are given in this from before, we know that dv dt equals 3, and that our time equals 12 seconds. And what we want to know is, again, how fast the radius, or is the radius increasing, which is dr dt. And to do this, we're going to use the equation v equals 4/3 pi r cubed. And so first we have to find, since no measurement for the radius is given, we have to first solve for r in our equation right here. And so since v of t equals 3t, so v of 12 equals 3 times 12, so v equals 36. So we plug that in. 36 equals 4/3 pi r cubed. So let's divide that by 4 pi over 3 on both sides. And that's really just multiplying by the reciprocal. So 36 over 1 times 3 over 4 pi is going to be 27 over pi equals r cubed. And since we're going to get r by itself, we have to cube root this. And so r will equal 27 over pi, or the cube root of 27 over pi. And so now we can plug this back into our equation, where v equals 4/3 pi r cubed, and we have to take the derivative of this, so dv dt equals 4/3 pi, then 3 times our r, which is cube root of 27 over pi squared times dr dt. And we know that our dv dt is 3, and these 3's right here can cancel out. So 3 equals 4 pi times cube root of 27 over pi squared dr dt. And so first let's just divide both these sides by 4 pi. So 3 over 4 pi equals, now I'm going to simplify this out here. So the cube root of 27 is going to be 9 over the cube root of pi. And we want to, the cube root of 27 is 3, and 3 squared is 9 over the cube root of pi squared. So that will equal 9 over the cube root of pi squared can also be written as pi to the 2/3. And from our equation above, that is multiplied by dr dt to equal 3 over 4 pi. And so now we want to get dr dt by itself, so we divide by 9 over pi to the 2/3 on both sides. And so that will be 3 over 4 pi times pi to the 2/3 over 9. And so these can cancel out a little bit. And so we get pi to the 2/3 over 12 pi. And so from our exponential rules, we can subtract the bottom from the top. So 2/3 minus 1 to get rid of this pi on the bottom. And 2/3 minus 1 is negative 1/3. So pi to the negative 1/3 over 12. And so since it's to the negative 1/3, we take that down to the bottom, which will equal 1 over 12 times the cube root of pi, or which is equal to pi to the 1/3. And that will be our answer. So the radius is increasing at a rate of 1 over 12 times the cube root of pi meters per second when the time is t equals 12 seconds.